Hello again. I'm going to do some integration using trig identities. The first example in this video will be ones that involve even powers of sine x or cos x, and I'm going to do that through two examples. I've got one here with the integral of sine squared x with respect to x and the integral of 4 cos squared 2x. Okay, let us start with the first one. So the integral of sine squared x. You cannot integrate that straight away. You can't just put it sine to the power 3 over 3 or anything like that. It doesn't work for trig functions. So we're going to change the way that it looks. We're going to change the way that it looks using the double angle formulae. When you're doing this, we'll look for sine squared in something that involves something that there's no squareds anymore. And the one that's most commonly used is the formula, this one, it's the cos 2 theta formula, and that equals 1 minus 2 sine squared theta. Now you'll find that on your formula sheet. You'll find for cos 2 theta there's actually three different versions of what you can get. One which involves sine squared and cos squared, one just cos squared, and one involving just the sine squared. Now I've chosen the one it's only got sine squared, of course, because I'm doing a question that has only got sine squared involved in it to start with. So that's why I'm choosing this particular version of cos 2 theta. Right, we must rearrange this to get sine squared equals something. So I'll subtract 1 from both sides, and I'll divide by minus 2, and that will be what sine squared theta is equal to. Just dividing that minus 2 in, that will give me half into 1 minus cos 2 theta. Okay, there is what sine squared theta is, and you'll have to do this bit of rearrangement every question depending on exactly what it looks like in the question you've got. So now from this I can say that therefore the integral sine squared x is equal to, I'll take the half out, with respect to x. Okay, and now I've changed it from something that you couldn't integrate straight away into something that you can, because when you've just got, you know, a linear thing here, cos of something linear, it's easy enough just to integrate. So we're going to get a half into integral of 1 is x minus integral of cos is sine. We must remember to divide by the derivative of that inside part, and we'll get a constant of integration as well. Just multiplying that out, then we get x over 2 minus sine 2x over 4 plus the constant. And that's that. So that you just have to choose your appropriate substitution. And I chose the cos 2 theta as 1 minus 2 sine squared because that's the only one that involves just sine squared, and that's what my question had. Okay, I will pause there and do another video doing my second example.